To this next session, which is essentially for me to introduce Daniel Libeskind, who's going to give this afternoon's keynote speech. I've worked with Daniel for almost 5 years now, and he is a really great person to work with, a great collaborator. And I'm very pleased that one of the projects that we're involved with together is the symbol of this year's conference. And I'm going to shed a little bit of light on this project, the Milan Fiera. But first I'm going to ask a few questions. I wonder how many of you actually recognize this project. You probably will understand it a little bit better like this, and potentially even more like this. Now, I wanted to show this for two reasons. One is that iconic buildings don't necessarily have to be enormous to be icons. But also, one of the topics of the conference is tilting buildings. And although it wasn't designed this way, it would be easy in this modern era to design a building that tilted like that. Technologically, this is not very difficult. Although achieving some of the stonework detailing was probably much more challenging. We've been doing tilting, twisting, tapering buildings for a long time. This project, which was engineered by Les Robertson, is a tilting building in Spain, the Puerto de Europa. And if you look at what is happening on this building, is that the center of mass is coming down where the red line is, so the total building weight is actually being supported on that red point. And Bill Baker said earlier that this building isn't really tilting because the center of mass is coming down on a particular point. The green arrows represent the push-pull that the building would have to resist as a result of seismic or wind loads. With a building of this height, probably supporting its weight is the biggest challenge. This type of structure is one of the many structures that are used for the tilting form. However, today's challenges are a bit more complex, and this is a project that we're doing with Asymptote, the Al Raha Beach Hotel, and this is one of the preliminary concept schemes for it. Our structural solutions, we are exploring many options, and this is the first option that we looked at, which consisted of a series of twisted columns that are both sloping, a spiraling floor, core bracing, and then some large cantilevers. And this is our preliminary analysis of the building. But like many of these really interesting ideas, one of the things that frequently happens is you start off very complex and trying to do something great, and as you get into the design, you meet some of the challenges and you modify the challenges, you modify the design, but you still end up with something great. And what we try and do when working with Daniel and other people is to essentially come up with a good structure that is economic, that actually meets the design aspirations of the architect. That was the steel option, this is the concrete option. Rather difficult to form because the slope, the faces, the walls are inclined and sloping. This is one of the structures we've looked at, which is a development of the first scheme. And what we're doing here is actually sloping the columns in the opposite direction of the twist. And as the columns slope, they generated a twist. So if you've got a square building and you slope all the columns around them in one direction, that building will want to twist. So if you have a twisted building and slope the columns the other direction, it helps to take the twist out. That becomes then a solution which is not going to move as much if you just rigidly follow the twist. This is another twisted building with the same architect. It's a competition for a project in Busan. And it's also a basic twisted form. This is our structural model. And what we did within this form is actually we had a series of, each floor plate is supported by 3 columns. And there's a model of it on the Arab booth at the table. And start on the outside of the building and lean in. And the lift columns start on the inside of the building and lean out. But since all these columns are actually concentric with the centric core, what you're able to do is create a twisted form, but there is actually no twist as a result of its own self-weight. That again maximizes the efficiency of the structure. This is a project that we're doing with Daniel in Warsaw. It's the Oracle project. And again, this is our structural model. And you can see the technique that we're using to actually create this very interesting form. I'm not sure if Daniel's going to explain why it's this shape, but I think that he probably will. There are several components to it structurally. When we've built inclined columns on a sloping face, we try and have them inclined only in one direction, and that way you can use conventional formwork and rectangular columns. For planning reasons, the building cantilevers over the main street, and we have therefore a big transfer structure shortly. And the things that happen with buildings that your floor spans they start changing. And one of the techniques that we frequently use to deal with this is that we would take a column up, and as the spans become large or too large, we start to split the column and have the column going off in 2 directions. And again, if you can have that column split going concentric, you're not creating any twist on the structure below. This is one of the early typical floor schemes. You can see that most of the columns are in fact vertical, and what ideally we try and do is create a very simple flat slab construction so that you might have sloping columns, but in fact the floor slabs are conventional. One of the things that I mentioned earlier is the building is cantilevering over the road, and it's doing this for functional reasons as opposed to whimsical reasons. And this is the type of structural challenge that you actually can face on many types of rectangular buildings. In this particular case, it's on an unusually shaped building. And what you can see is happening is the vertical load is coming down and is causing the building to lean over. And that leaning will occur as you build it, and being a concrete structure, you will actually get a long-term lean so that the building will continue to lean as the concrete retreats. And therefore, one of the things that you have to do as you're planning these buildings is you have to be able to tell the contractor what's going to happen as he's building. And you also have to design to accommodate and build in the capacity to let the building move in the future. A talk with Daniel and I sharing a podium wouldn't be worth it without mentioning the Freedom Tower. And since I'm not allowed to mention it, we won't talk about it in any more detail. But we will briefly talk about the Milan Fiera project. And one of the things that is quite interesting about this building is some of the studies that we did and developed with Daniel after we had won the competition, looking at how we can optimize and make the building efficient and effective. And the diagram, this is also our structural model. And what you can see is that the building is a direction, and it's taken from a sphere, so the curves are uniform. And the building is, instead of leaning back instead of just leaning forward, is leaning back and forward. And what that does is puts the centroid of mass over the middle of the support. So effectively at the base, you've got your maximum wind and earthquake moments, but you've got a very balanced structure, and as far as the bottom of the building is concerned, it could as well be vertical. Of course, the mid-height of the building is where you get your maximum bending moments and the maximum force in the elements. But there is a compensation because you've got a reduced vertical load, so you tend to get a balancing of structural elements as you go up. This is an extract of the building showing the typical 20-meter floor cut plate. Again, it's not an enormous tall building. It's a medium rise building, but it is adding a character to the whole development, which the client is very pleased with. Now, when the scheme that we've got now is not necessarily the scheme that we started with, and this is some studies looking at changing the curvature to try and get to see what effect and what benefit on the structural sizes and what effect on the aesthetics these different configurations would be. And this just shows some lateral deflection analysis on the same models and some impacts on the same models. Clearly, the more vertical you get, the less the dead load is actually dominating the design. We also looked at the spacing of the bracing system to determine what would be the most effective and the most efficient. And again, this is the load path. As with the other buildings, this building will tend to move as you build it because it's initially leaning backwards, so as you're building up, it's wanting the full structure is not there, and it's the full structure that gives its integrity. So even at the early stages with this type of building, you can't just look at the finished product, you've got to figure out how you're going to get there. And with that, it's a great pleasure to pass this over to Daniel Libeskind, who's going to tell us his thoughts. Please welcome him in the normal way.